The equation kx squared minus 2kx plus 3 equals 0, where k is a constant, has no real roots. Prove that k satisfies the inequality k is greater than or equal to 0 and less than 3. So the quadratic equation there has no real roots if the discriminant is less than 0. So let's use that fact. We can see that a, in this case, is k. B, in this case, is minus 2k. And the c is 3. So substituting those into the discriminant then, we've got b squared minus 4 times a times c has to be less than 0. Minus 2k times minus 2k is 4k squared. Minus 4 times k times 3 is minus 12k. I can divide through by 4 to make this a little bit simpler. And factorise the k outside. So that I can now draw a quick graph with my roots. I can see that I've got a root at 0 and another root at 3. So I can say that if k is between 0 and 3, then the discriminant is negative. I've just drawn the graph of the discriminant, and the discriminant is negative if it is between, if k is between 0 and 3. So b squared minus 4ac is less than 0 if k is greater than 0 and less than 3. But just go back to the question. Notice I need to explain about the equals 0 as well. I've not explained that yet. I've only explained about if k was between 0 and 3. Well, let's go back to the original question and see what would happen in that case when k equaled 0. If k equals 0, then I would have 0 times x squared minus 2 times 0 times x plus 3. 0 times x squared is obviously 0. The minus 2 times 0 times x is obviously 0, and we get plus 3. So all of that is just 3. And that cannot equal 0. This cannot have a solution if k equals 0. So showing that means I can now say that not only will the discriminant be less than 0 if k was between 0 and 3, but if k was between greater than or equal to 0 but less than 3, then there is no real roots. This is showing how there's no real roots if k equals 0, and this is showing how there's no real roots if k is between 0 and 3.